In today's video, we're looking at how we can create visualizations to improve data-backed decision making. So the first graph that we're going to create is our histogram. We're going to look at the histogram of RPE so we can see the distribution of RPE throughout the course of the season. And then we have our slicers on the dashboard so we can filter it by name or session type, the date, or the position of the athletes. I'm going to select the clustered column chart and we're going to position it on the lower right hand side. And then we want to look at RPE, so we're going to put RPE on the x-axis. And then because it's a histogram, we're using RPE again. We're looking at that on the y-axis, and we want it to be the count of RPE on the y-axis. Now, when we plot this here, we see that the RPE is not sorted by RPE on the x-axis. It's sorted by the counts of RPE. So ideally, we want to take a look at it from smallest to largest. So we're going to go to sort axis. We're going to sort by the RPE. Once it does that, it gives us the NAs right here, and then it gives us from highest to lowest. I'm going to flip that to lowest to highest. So again, sort axis, sort ascending, and then it gives us from lowest to highest. It still includes the NAs. So what we can actually do is highlight our visualization, go to our slicers here, and then under RPE, select all, and then we're going to unselect RPE or NA, and then there it has adjusted it. So now we have from 4 to 8, and we're not seeing any of our NA values there. Next, to help us visualize z-scores, we're going to use a gauge chart in Power BI. So we're going to select our gauge visualization, and we are going to bring it up to the upper right hand corner here. We'll adjust the size of it here. Now in our last video, we already created a z-score. What happens though when we add our z-score to the value pane here is going to give us the count of z-score. We don't want the count of z-score. We're going to do the average of z-score here. But what happens is it doesn't show us the minimum or the maximum value. So what we could do is we could select the z-score again, and then under minimum value change it to the minimum of z-score. And so it shows us negative 0.166 is our minimum z-score. But what happens is if we change the name of the athlete, so if we only look at Aaron, we see that the minimum z-score changes, which it shouldn't. So the way that we can make sure that this doesn't happen is we can go to our data view on the left side, and we can actually calculate the minimum, the maximum, and the average z-scores. So what we're going to take a look at here is the minimum. We're going to create a new column, and what we're doing it is we're calling it min, and it's going to be the minimum of our data frame name and then the column. So then it returns the minimum value. We see that it's consistent across the board here. We do the same thing for max, and we do the same thing for average. That way, instead of having a minimum, max, or average that changes when we use our slicers, we can use one consistent measure for all of them. So we're going to select minimum. We're going to drag it to the minimum value. We don't want the sum of that. We want the average. Same thing for max and for average. So we're going to come over here, maximum value, and then average, drag it to the target, and there. So now we see that negative 0.166, positive 1.57. So now if we go back and we change it just to Aaron again, we see that it stays at negative 1.66 and positive 1.57. So we can see how Aaron's values compare to the rest of the team. The last visualization that we're going to create in Power BI is going to be the scatter plot. Now we can create our scatter plot using the plot that's given in Power BI. However, because there's a lot of duplicate values from our RPE, it's not going to really show the best relationship between RPE and distance. So what we're going to do is we're actually going to import a R script visual to show the relationship between RPE and distance. So to import our R script visual, we're going to hit this R script visual, and we're going to enlarge the size of it a little bit more here. And we're going to drag the values that we need. So we need to take a look at the distance. So we're going to drag distance into our values here. And we also need to take a look at RPE. We're going to change this really quickly. We don't want the sum. And then we need the RPE. So once we've added RPE and distance to our values, we're going to treat this pane here like it's our studio. So we need to install dplyr and tidyverse, and then we're using the repository of the cran.us.r project. From there we're going to create a ggplot, and our data is going to be called data frame, or data set rather. So up here it automatically renames it to data set. So it's not going to be our data frame name that we see here on the right side. It's going to be called data set. And then we're looking at the aesthetics. The X is going to be RPE and the Y will be distance. And we're looking at geom jitter. We want to use geom jitter as opposed to geom point, because geom jitter is going to show slight variations in the data that make it a little bit easier to understand. We're also going to use geom smooth to add a trend line so we can see the trend of the data. So geom smooth, and then from here we can run all these lines of code, and it'll take a couple seconds to produce our visualization, but here in a second it'll pop up. Now that our R script has run, we can see our visualization here, and we can see that as a general trend that there's a positive relationship between RPE and distance. And so we can kind of see that there's some clusters here in RPE, but that geom jitter really kind of helps separate some of these values, so it makes it look a little bit more appealing and easier to understand. I hope this video helped you visualize statistical tests to help improve data-backed decision making. Thanks.